Every time you click buy or submit a secure password or even just toggle a website into dark mode, you're actually interacting with a ghost.
Oh, ghost. I like that.
Right, because you trigger this piece of code that wakes up, builds a custom web page specifically for you, hands it over, and then, well, it completely obliterates itself before the data even hits your local router.
Yeah, it's totally invisible to the user.
Exactly. You never actually see the application. You only see the exhaust it leaves behind. So welcome to the deep dive. Today we're taking a look at this massive architectural shift. We're going from just fetching simple static documents to, actual dynamic server-side magic.
It's arguably the most critical paradigm shift in any web developer's education, really.
Absolutely. And our source material for this is a presentation deck from a web programming course. It's a iTech 1030, specifically Chapter 7, which focuses entirely on PHP. And our mission for you today is to explore the exact mechanisms of how a server shifts from being just a dumb file cabinet into a real active computing node.
Up to this point in the curriculum, right, every visitor just got the exact same .html file.
Yeah, these students have basically been building purely static architecture. Like they've mastered HTML, they've styled it with CSS, and, they've added client-side interactivity with JavaScript.
But the server's just sitting there.
Exactly. The server's role has been completely passive. The client asks for a file, the server grabs it from the disk and sends it over. Every single client gets the exact same bytes. But Chapter 7 introduces the server-side request and response cycle, where the server actually intercepts the request and dynamically computes the response on the fly.
Okay, let's unpack this. Because that leap from passive file delivery to active computation, it introduces a massive boundary layer.
It really does. And the source focuses on PHP as the engine for this. There's this one specific detail from the slides that I think perfectly illustrates the illusion of it all. It says PHP runs entirely on the server. So by the time the HTML reaches your browser, the PHP code is entirely gone.
Poof, vanished.
Yeah. Like when you hit view source in your browser, you never ever see PHP. You only see the HTML it produced.
It's a fundamental separation.
I was thinking about it like a chef in a restaurant kitchen.
Oh, I like that analogy. Go on.
Right, so the server takes your order, and the chef, which is PHP in this case, prepares a totally unique meal, the HTML. But the chef never comes to your table. You only get the finished plate. You never, get the recipe.
What's fascinating here is the absolute necessity of that isolation, mostly from a security standpoint. Think about it. If the server delivered the PHP script to the client the same way it delivers a JavaScript file,
Oh man, that would be bad.
it would be a disaster. It would expose the internal business logic, the database credentials, the whole file system architecture to the public internet.
Right, anyone could just look at it.
Exactly. The web relies on this zero-knowledge proof. The client asks for an action, and the server provides the result without ever revealing how the sausage is made. And, to enforce this, the source notes a really crucial detail. The file has to have a .php extension.
Not .html.
Right. That extension isn't just a label. It's the specific trigger telling the web server daemon, hey, stop the standard file transfer, hand this over to the PHP interpreter, and, wait for the computed output.
Because if you just leave it as a .html file, the server daemon bypasses the interpreter entirely, right? It just serves raw PHP code in plain text.
Which, again, is a catastrophic security leak.
Yeah, definitely don't want that. So, assuming the server correctly routes the file to the PHP engine, the source then dives into the actual syntax of the invisible brain. And reading through it, I was struck by the cognitive friction this must create for a student.
Oh, the context switching is brutal.
It has to be. Wait, didn't the source say they just learned JavaScript in Chapter 6?
They did, yeah. Just the chapter before.
Why learn another language immediately? Now everything has to be inside these weird little angle bracket, question mark PHP tags.
Yeah.
And the formatting is so quirky. Variables don't need a declaration keyword, but they absolutely must start with a $sign.
Right, like $name.
Yeah. And the echo command prints text. But the craziest part to me, you join strings together with a period, not a plus sign.
Yeah.
Asking them to pivot to a completely different language with its own highly specific idiosyncrasies right away seems, really hard.
It is notoriously difficult. But, the course developers clearly saw that hurdle coming. The way the presentation handles it is actually brilliant.
How so?
Well, instead of just dumping a new dictionary of syntax on them, it actively maps the new language to the mental models they just built in JavaScript. It points out that the underlying logic shape is exactly the same.
Oh, interesting. So the logic is mastered, just the vocabulary is new.
Precisely. Like an if-else statement, or using double equals for comparison, or exclamation point equals for not equal to. All of that evaluates identically to JavaScript.
Okay, that makes it a lot less intimidating.
Yeah, the slides are basically saying, hey, you already know how to engineer the building. We're just asking you to use a slightly different brand of hammer. It abstracts the logic away from the syntax.
That is super smart. So, okay, we have this execution environment completely isolated on the server, and we understand how PHP thinks and makes logical decisions. But how does the browser actually talk to it?
Passing notes to the server.
Right. How do you pass it information? The source outlines two main methods for users to send data, $_GET and $_PST.
Yes, GET and post-T.
And the examples they use are really different. For a GET request, they talk about a light or dark mode toggle, which basically just reads a value right out of the URL, like $mode equals dark.
Simple and visible.
Very visible. But then, for the newly introduced feedback form, they switch entirely to POST, which sends this hidden body of data. So my question is, if GET is so easy because it just tacks data onto the URL, why do we need POST at all? Like, why not just use the URL for everything?
Well, it's entirely about intent and visibility. The ET method, like the slides point out, is designed to be visible. Because the variables are baked right into the URL, it's bookmarkable.
Oh, right.
Yeah, you can share that dark mode URL with a friend, and they'll get the exact same state from the server. It's great for simple links.
But not great for private stuff.
Exactly. Imagine submitting a secure password or a massive multi-paragraph feedback form using GET. Not only would your URL be unmanagedly long, but it would expose sensitive data in plain sight.
Like in the browser's address bar.
Yes. And in the server's access logs, the router logs, your browser history, it would be a mess. That's why POST is essential. It encapsulates the data payload within the hidden body of the request itself. It keeps all that messy or sensitive data out of the URL completely.
Okay, so since we're now submitting form data via POST, I guess that brings up a huge issue. What happens if the user submits garbage data? Or just leaves fields blank?
That is where the unskippable bouncer comes in.
The bouncer. Yeah. Right. The source introduces server-side validation here, specifically using PHP's empty function to check for blank fields before it processes anything. But it mentioned that they already learned HTML5 and JavaScript validation in Chapter 6.
They did. Client-side validation.
Yeah, and I was thinking client-side validation is basically like the velvet rope outside a nightclub, right?
I love that.
It
Yes.
keeps the honest people out, gives a nice UX, tells you if you forgot an @ symbol in your email. But someone determined can totally just jump the rope. They can bypass the browser entirely.
Easily.
But server-side PHP validation, that's like the giant vault door inside the club.
Yes.
It simply cannot be bypassed because the data has already arrived on the server.
If we connect this to the bigger picture, you're talking about the concept of layered defense. The slides highlight this specifically. HTML5 and JavaScript catch mistakes early. It's great for the user experience, but the server cannot, under any circumstances, trust the integrity of the data it receives.
Because you don't own the client's browser.
Exactly. A malicious bot could easily send a malformed POST request directly to the PHP endpoint. So PHP is the indispensable last line of defense. The empty function acts as that vault door. If validation fails there, the script just halts.
So it's completely zero trust.
100% zero trust.
Okay, so we've received the data, and the bouncer checked it. It's validated. Now, the final step. PHP actually has to do something useful with it, right? It has to leave a permanent mark.
Right. It's time to mutate state.
The source outlines two major actions here. First is file put contents, which writes the data straight to a server file. But there's this crucial little detail highlighted, the file_append flag.
Oh, that flag is so important.
Right, because without it, you're just overwriting the whole file every single time someone submits the form. But with file append, it just adds a new line to the bottom.
It shifts it from being destructive to being accumulative.
Exactly. And the second action is sending an email using PHP's built-in mail function, which is cool because it just takes three pieces to address the subject and the message. You don't even need external libraries.
It's remarkably simple on the surface.
On the surface, yeah. But I spotted this massive caveat in the slides. It says the mail function can silently fail. Like if the server isn't configured right or lacks permissions, it just doesn't work, and it doesn't even throw an error. I mean, you can't just assume it works.
No, you really can't. And honestly, it is a brilliant real-world lesson for a developing engineer. It breaks the illusion that your code exists in a vacuum.
Oh, totally.
Up until now, their code was self-contained, but mail relies on the underlying operating system infrastructure. If the OS isn't configured to send mail, PHP does its part, hands it off, and then nothing happens. It teaches them that their application is tied to the physical environment it runs on.
So what does this all mean for the big picture of the course? The slides actually have this grand finale titled, Where the Data Goes From Here.
Ah, yes, tying it all together.
Yet PHP is now reacted in real time by toggling a style sheet, saving persistent data, sending an email. And it mentions this is the exact skill they'll use in assignment 2. They have to wire up this dead form they built in chapter 6 to finally do something real.
It's the moment the web goes from being just a digital poster to an actual interactive application.
And it's super satisfying. So just to summarize the journey for everyone listening, we took static HTML pages that always looked the same. We added an invisible server-side brain using PHP. We learned how to pass it information via URLs and hidden forms.
Yeah, GT and post.
Exactly. We secured it with a vault door of server-side validation, and finally we actually stored that data and sent emails. I mean, you now understand the basic mechanics behind almost every interactive website out there.
You really do. But, this raises an important question, and it's a bit of a puzzle that the source material hints at, which I think is a great provocative thought to leave you with.
Oh, let's hear it.
So, the presentation mentions that saving data to a simple text file, that feedback.txt, is just a simple stand-in for Chapter 10, which introduces real databases.
Right, it's just a placeholder for now.
Exactly. But I want you to imagine what happens to that single feedback.txt file if 10,000 users all click submit at the exact same millisecond.
Oh, wow.
Right. You have 10,000 independent PHP scripts waking up simultaneously, all trying to open the exact same flat file, write a line, and close it. Can a simple text file handle that kind of massive concurrent traffic without corrupting?
That sounds like a recipe for a server fire.
It absolutely is. There's no traffic control. And that massive complexity of scale, that is exactly why we need true databases. But that is a leap in web architecture for another day.
A perfect cliffhanger. Well, thank you so much for joining us on this deep dive. Yep. Hopefully the next time you submit a form online, you'll think about that invisible ghost in the machine doing all the heavy lifting behind the scenes. Keep exploring the invisible logic around you, and we'll catch you on the next one.